Okay, now on to finding the right module. So when we talk about finding the right module, what we're saying is we're looking for a DLL or something similar inside of a program that has no memory protections, meaning no DEP, no ASLR, no safe SEH, etc. Now there's a tool out there called Mona Modules that we can use with Immunity Debugger to achieve this. So if you go out to Google and you search Mona Modules, you should be able to find a GitHub page for it. You're going to need to download this mona.py file and put it in this specific folder here. So the specific folder is this PC, program files x86, Immunity Inc., Immunity Debugger, Py commands, and you're going to paste it right into here. So go ahead and do that, and then once you're ready, let's go back to Immunity Debugger. And now I already have the program attached, Vuln servers here. And what we're going to do is we're going to actually type in this little bar down here. So what you can type in is exclamation Mona modules and hit enter. So that'll pop this guy up here. And if you look, what we can see is these protection settings right here. Look, we've got false, 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 false across the board for some of these protection settings. And that's what is ideal for us, right? We've got trues on some of these other things, but really what we're looking for is we're looking for something attached to Vuln server itself, which you can see this Vuln server right here, and we're looking for all falses. So a prime candidate immediately right away is this essfunc.dll. So we're going to go ahead and just keep that in the back of our minds because we actually need to do one other thing. Now, if we know this by memory, we can go ahead and type it out right here, but I want to show you the process for actually finding what we're about to do. What we're about to do is find the opcode equivalent of a jump. So let's go ahead and look at how to do that. To do that, we're going to go into Kali Linux, and we're going to locate something called NASM shell. So we'll just type locate NASM shell, and go ahead and just copy this Ruby right here, and then paste it in like this and hit enter. So when we say we're looking for the opcode equivalent, we're trying to convert assembly language into hex code. So what I'm doing is I'm going to type in this assembly language, this JMP ESP. This is a jump command. So what we're going to do is we're going to use this as a pointer. So the pointer is going to jump to our malicious shellcode, and that'll make more sense here in just a little bit. So the hex code equivalent of JMP ESP is FFE4. Okay, so now what we're going to do is we're going to take this information, this FFE4, and we're going to go back into Immunity. And we're going to type this instead. So let's delete the modules part. We're going to keep Mona. And we're going to say Mona find. We'll do a -s. And we're going to say XFF/XE4. And then we're going to say M for module, and we're going to use this essfunc.dll. So if that makes sense, we've got our opcode equivalent here, the FFE4, and then we've got the module of essfunc.dll, which is right here. Again, we chose this because it goes with the Vuln server program, and it has no memory protections. So this is a good candidate for what we want to do. So let's go ahead and just hit enter on this guy. Okay, and I think I forgot a slash here. Let's check this out. Okay, so that is better. So what we're looking for here is we're looking for these return addresses. So if you look at this 625011AF, that is going to be a return address. So let's go ahead and just write this one down. We're going to go right down the list and find what works. So I always like to start at the top, and you can see here that it found this essfunc.dll, and it's got all the memory protections here listed as false. So now with this information, what we're going to do is we're going to go into Kali. We're going to just type exit here on this NASM shell. And we need to edit our Python script. So whatever Python script you're at, I'm still on 2.py, go ahead and open that guy up. Let's delete out the bad characters because we did already find those. And now what we're going to do is we're going to delete out this B4. So let's write in real quick what our return address was. Remember, it was 625011AF. So now, instead of having 4 B's in place of the EIP, we're going to put this pointer there. So we're going to have the EIP be a jump code, and then the jump code is going to go to malicious code. So we're going to enter that in here. Now we're going to enter it in a little special. So what we're going to do is we're actually going to enter it in like this. We're going to say /XAF/X11/X50/X62. If you notice, this is actually in reverse. So you see AF115062. We're doing this reverse for a special reason. So when we're talking with x86 architecture, we're doing something called little endian format. So x86 architecture actually stores the low order byte at the lowest address and the high order byte at the highest address. So we actually have to put this in reverse order. So what this should do now is this should throw the same error before, but it's going to hit a jump point. So we can do something special in Immunity to actually catch this. Let's go ahead and hit save on this script. And let's open up Immunity again. So let's go ahead and minimize this. And let's maximize this guy again. Okay, so we're going to do something special here. So first what we're going to need to do is we're going to need to click on this little arrow here. It's kind of bluish black. And we're going to enter in this expression to follow, 625011AF. So remember, that's going to be our jump code. So if we hit OK, we should find this FFE4, this JMP ESP, right? And this is perfect. This is exactly what we want right here. So what we're going to do is we're going to hit F2. So F2 will turn it blue. And what we have just done is we've set a breakpoint. So we have the breakpoint running. What this means is we're going to overflow the buffer, but if we hit this specific spot, this jump code, it's not going to jump to further instruction. It's actually going to break the program and pause right here for further instruction from us. And that's all we want. We don't have anywhere to jump to right now, so it's not important. We just need to know that we are hitting this, we're overwriting the EIP in the exact spot we need to, and then we're going to be able to jump forward. So let's go ahead and hit play here. And then what we're going to do is we're going to go back into Kali and we're going to execute our script. So let's go ahead and do that. We'll say 2.py here. Run that. Oh, you know what I did? Apologize here. I never deleted the original code here. So if you caught that, good job. Okay, let's go ahead and try that now. Okay, so we ran it. And what happened? You see breakpoint at ESSFunc.625011AF happened. The program is now paused. We have hit our breakpoint. That means we control this EIP. Look at this, 625011AF. We control the EIP. Now all we have to do is generate some shellcode, point directly to that shellcode, and we are home free with root. So we're going to go ahead and do that in the next video, and I will catch you over there.